Maayong adlaw. Niya na sabta karon para sa atong leksyon sa industrial motor control. But this time, I will be giving you sequential control. Now remember, we are not done yet the reduced voltage, but I'm going to give you first the sequential control so that I can also give you some activities that you will be doing. Then maybe an assignment. I will give you problems, then try to practice, because this will be given to you or serve as your part of your final exam, no, before the end of the semester. So this morning I will give you sequential control. Now, sequential control is very important. Now, a typical example of sequential control is the elevator. Diba? So, in elevator, you have many stories, many floors. So, then what is the name of the controller? That is sequential control. Okay? So, even in conveyor, it's also applied in conveyors and any other applications. So, sequential control is very, very important. So, I'm going to give you some basic sequential control diagrams. And of course, I will simply give you the conditions, and with the knowledge that you learn in our basic industrial control, particularly the 4-volt running starter, then you will now have an idea on how to connect it. I also introduce to you the different parts of the motor controls. Then briefly, I explain the principle of operation for every part. So by that, you may review that video, particularly the principle of operation in every part. Okay? So, I have here a sample for sequential control. Basic, very basic. I have only here two, no? Look here. So this is a sequential control. So we have here conveyor number 1 and you have here conveyor number 2. Okay? So the problem here, conveyor number 2 will only run when conveyor number 1 is energized. Sa ato pa, if you have another push button for conveyor 2, you will press immediately the button start of conveyor 2 without pressing first the conveyor number 1 or running first the conveyor number 1. This will not work. Okay? This will not work. So what you will do first, run this, press the button in conveyor number 1, and when the motor or the conveyor number 1 is already running, that's the time that you will on the push button for conveyor number 2. So that is what we call sequential control. Now you will press or run this motor manually. But there is also another way. Here you press button number 1 and button number 2. But there is also another way of running these two motors, but still a sequential control, by using a timer. But this time, you will only press once. You will only press the button number 1, then just wait for a few seconds, then automatically motor number 2, or rather the conveyor number 2 will run. That is because you are using time delay relay or timer. So you don't need to worry, because there would be one video not intended only for different types of time delay relay, the on delay and the off delay. Initially, I already discussed the difference between on and off delay. But for the details, then watch for that video. Okay? So this is it. So look at that. No? Again, the problem, conveyor number 2 will only run when conveyor number 1 is energized. So you will run it first. That's the time that you will press the button for number 2. So I will illustrate to you the power and the control circuit of this problem. Here is now the power circuit for that problem. No? What is the problem? Conveyor number 2 will only run when conveyor number 1 is energized. That's the problem. Okay? So I will give you more problems. The same power circuit. So you have here the conveyor number 1. This is your conveyor number 1 motor and conveyor number 2 motor. You have here. So you have one circuit breaker here. We have main contactor for control conveyor 1. Then another magnetic contactor for conveyor 2. Now, if you have a 5 horsepower here, you have also a 5 horsepower here, of course, the magnetic contactors are identical. But if ever the horsepower of this motor is 10 horsepower, and then this is only 5 horsepower, though you are still using contactors, but the rating of the contactors are already different. So if this is 10 horsepower, this is 5 horsepower, so see to it that the magnetic contactors is intended for 10 horsepower, while the other one is only for 5 horsepower. Okay? So always remember that even the overload relay and the size of the wire to be used here. So again, there is a calculation what will be the size of the wire to be used for motor conveyor number 1 for because this is 10 horsepower and then this is 5 horsepower. So of course it is understood that it has different size of wire to be used here. Even the size of the contactors. Okay? So you have here the power circuit. So the power circuit is not a problem. So maybe you will have different conditions here, but still the same power to be used. Now, how would you have that diagram? This is the power circuit. So of course, there is also here another one, no? So you have your overload contact. Don't even forget overload contact. Then considering that you have what we call 2 contactors, so you should have also 2 overload relay contact, diba? So this is OLC1. Then this is your on button. This is intended for conveyor number 1. Okay, that one. So this is your conveyor number 1 and this is for line 2. Then you have your maintaining contact, that one coming from conveyor number 1. Okay, so that is, so if I'm going to press the button here, this one will run. Now remember, conveyor number 2 will only run when the conveyor number 1 is energized. So what would be the next? Okay, so we have another push button here. That one, stop. So this is a off button for conveyor number 1. Then this is the start button for conveyor number 2. Then we have here, so this is also your maintaining contact for your conveyor number 2. Then you have your conveyor number 2 holding coil. Okay, look at this. Now this is not the correct diagram, but I will tell you first the difference. So I said motor conveyor number 2 will only run when conveyor number 1 is energized, right? But this time, if I'm going to press immediately the push button 2 intended for conveyor number 2, what will happen? Immediately the motor will run, even without running the conveyor number 1. Diba? So how would you meet the condition? So of course, this time, you will utilize an auxiliary contact normally closed. And where you will get this normally closed contact? Coming from a normally open contact, coming from conveyor number 1. So look at this. So this is your, that is an interlock. Tama ha? You listen it. If I'm going to on this immediately without pressing this one, do you think that there is a current that will continue flowing to contactor number holding coil number 2? No. Why? Because this is still open. And why is it still open? Because the conveyor number 1 is still not running yet. So what you will do? So once you will press the button here, this will energize. Of course, this will close. Then that's the time that you will switch on. Okay? Again. So in this kind of diagram, if I'm going to press the button immediately, the button number 2 intended for conveyor number 2, it will not run. Why? Because there is a normally open contact taken from conveyor number 1. So what you are going to do, you have to close this one first by running the conveyor number 1. So if you will press the button here, energize, this will close, then this will also close, then the motor is running, meaning the conveyor number 1 is running, then that's the time that you will press this button. So when you press this button, of course, there is a complete path of current going to your magnetic coil for conveyor 2. Then the motor now is running both. Now, another, by looking at one, let us see, this is already running. No? This is already running. Then you will try to off this. If you will off the push button number 1, that is intended for motor number, conveyor number 1, of course, this will open, right? So once this will open, automatically, this is also disconnected from the circuit. Okay? So if you will off number 1, so meaning to say, you can off the motors at the same time by pressing button number 1. But, if ever this is still running, then you want to off motor conveyor number 2, it's still the same. But the conveyor number 1 is still running. But if you will off button number 1, I mean this one, this will be off. But if you will only off this one, still the motor number 1 is running. That is sequential control. Okay? So that is it. Now, remember, I put only here overload contact 1, diba? So this overload contact 1 is only intended for conveyor number 1. What if there is trouble or overload in the conveyor number 2? There is no protection here in the absence of the overload contact. So what you are going to do? There's really a need for you, no, to place an overload contact here. Then you have also another overload contact here. Okay? Then, that way. So if there is an overload here, the motor now is running, the two motors are already running, the conveyors are running, then there is an overload here in conveyor number 2, of course this will open. Okay? So motor number 2 now is not running anymore because of the overload. But remember, this is still closed because conveyor number 1 is still running. That is it. So if motor number 1 is overloaded, or the conveyor number 1 is overloaded, of course this will open. For instance, that is closed. This will open. Okay? This will open. Okay? So once this will open, what will happen to this? This is de-energized. Meaning to say, disconnected from the circuit because this is already open. Then what will happen to this contact if this is open? This will also open. Meaning to say, when there is an overload occurred in conveyor number 1, then it trips off because of the overload contact, including conveyor number 2. But remember, only conveyor number 1 is overloaded. But considering that the conveyor number 2 is dependent to conveyor number 1, so if this is off, at the same time, this will also off. Okay? So, if ever there is, as what I have, again, if there is an overload here, this will open, but still, motor number 1 is still running. I hope you get it. Okay? I hope you get it. What is the condition? When conveyor number 2 will only run when conveyor number 1 is running. That is it. But I'm going to add another condition. No? In the condition here, you listen, in this condition, any of the motors is overloaded, the two will be off. Any. Remember, in this problem, not any. Because if the number 2 conveyor is in overloaded, still conveyor number 1 is running. Diba? So, conveyor number 1 is not affected when conveyor number 2 is overloaded. But this condition now will be like this. Any of the conveyors here is overloaded. Both of them are off. But remember, only one, either. If this is overloaded, off. If this is overloaded, off. So that is the difference between the two conditions. Okay? So how would you connect? Very simple. Look at this. Okay? You have this, oh. You just simply interchange this contact. So what you are going to do, you just simply connect the two overload contact. This is OLC1, this is OLC2. No, OLC2. Then you have your line 1 here. Then you connect this here. Okay? So you connect your overload contact in series. For instance, if conveyor number 1 is overloaded, so what will happen to the OLC? This will open. No more current is flowing to the two motors. Right? Because conveyor number 1 is overloaded. Now, how about if motor number 2 is overloaded? This will again open because number 2 is overloaded. Still, no current will be flowing to two contactors or conveyors. But remember, only one is defective or overloaded. See? That is the difference. So this is sequential control. So there are two conditions. Okay? First condition, when conveyor number 2 will run when conveyor number 1 is running. Another condition is when one of the motors or any of the motors is overloaded, both of them are disconnected or not operating. So this would be the condition. Okay? Remember the condition, huh? Remember that are the second condition. What if the third condition will be like this? How would you know what motor or what conveyor is in trouble? Remember, both of them are open, but only one is overloaded. But you do not know which of the conveyors is open. So this time, what you are going to do is, you have to place an indicating lamp. Okay? I give you already a load lamp, power lamp, as well as the trip lamp. But this time, we want to know which motor is overloaded, then we need a trip lamp. Okay? Okay, so you need a trip lamp. Okay, this is now the diagram of your control circuit. So I will erase the power circuit so that this will be clear. Like that. Huh? So you have here. So you will notice that we have now the overload contact normally open. We have normally closed contact, normally closed. So this OL1, this is for conveyor number 1 and this is for conveyor number 2. Okay, this strip lamp is for conveyor number 1 and then this one is for conveyor number 2. And look at this. When I press the button, both button number 1 energize, then this will close. This will also close, this will also close. Meaning, both motors or both conveyors are running. It so happened that one of the motors is overloaded, either number 1 or number 2. So let us see, number 2 is de-energized, overloaded. So the normally closed become open, and the normally open will become closed. Why? Because the contact here will transfer to normally open. So considering that this is already open, look at this, this is already open, so no more current flowing to both conveyors from this circuit here. So no more current. So the current now is flowing to this portion. It lighted the conveyor number 2. Conveyor number 2. So if the conveyor number, trip lamp number 2 is lighted, no, or lights, meaning to say that the trouble is the what? The trouble now is the conveyor number 1. Okay? This is your OL1. There is an overload occur here. So the overload contact opens. And then the overload trip lamp number 1 is lighting. So by looking only the indicating lamps, I know which of this motor or conveyor is overloaded. So I am very sure that the motor or the conveyor that is overloaded is conveyor number 1 because of the indicating lamp. So the same thing will happen if number 2 is defective or overloaded. So this will open. Okay, and this will close. So this portion here up to this portion, including this one, is not lighting. Look at this. So conveyor number 2 and conveyor number 1 are already open. Why? Because of overload. Then the contact will transfer here. Only trip lamp of conveyor 2 is energized. So I know conveyor number 1 is defective. Okay? So that is sequential control. Now remember, there are only 2 motors that I put here. There are only 2 motors. So what if there are 3 conveyors, 4 conveyors, and then each of these last 3 conveyors are dependent to number 1? So that is sequential. So that would be another problem. Okay? That would be another problem. Now remember, we are doing this manually by having 2 push buttons. But there would be another diagram, the same problem, but another diagram, because the condition is after few seconds, conveyor number 2 will cease to operate. Meaning to say, we are now putting or installing a timer. Okay? A time delay relay. You have only 1 push button, then conveyor number 2 will automatically runs after a few seconds because of the timer. Then that would be another video for that purpose. But before giving you that problem, I will explain to you first the principle of time delay relay, particularly the on delay and the off delay. Okay? So I hope you get sequential control, and then this for today. Then just view so that you can understand. In our laboratory, we have an instructional mock-up for this purpose. You can call it. Okay? You can call it. You don't need to worry if the pandemic is here. So again, thank you. God bless us all. Good day.